Good morning everyone, I am Mr. Ish. We are looking here at type 2 improper integral practice. Two questions. Our very first question is this integral we have over here. Lower limit 0, upper limit 1, 4 divided by x to the power of 5 dx. Remember, from now on, we always have to be able to mentally distinguish between a proper and improper integral. When we're looking at this rational function, we know an x value here with 0. We would end up having an undefined if 0 were within the domain of this function. So that tells you very well that there's a vertical asymptote present here at x equals 0. What that means is we're looking here at an interval in terms of domain notation would be 0 up to 1 including 1. But you see how this helps and guides you to establish the limit over here. Our limit would be established such as this limit as t approaches this 0. Because we're looking here from 0 to 1, we would be approaching 0 from the right. We wouldn't approach it from the left because we're not even looking at any values below 0. You would have something which would look like t and then 1. 4 over x to the power of 5 dx. You know this right here is an easy one in terms of its antiderivative. We can come down here and do it. We have 4x to the power of minus 5. You'll do plus 1 and then minus 5 plus 1. That's exactly how this will play out. What are you going to get? You'll have 4x to the minus 4 over minus 4. You'll have minus x to the minus 4, which is minus 1 over x to the 4th. That right there is your antiderivative, which will play right that value and then we'll bring it into form. We're looking here now, limit as t approaches 0 from the right, we'll have this minus. We'll bring the minus right here at the very beginning. We'll have 1 over x to the power of 4. We're looking at everything here from 1 up to t. Technically, we're going to put the parentheses right around this x component. There's nothing wrong with what I've done over here. We here now have to do the definite integration step by putting the upper and the lower limit. We'll be looking at right here 1 over 1 to the power of 4 minus 1 over 0 to the power of 4. What do we end up getting over here? You can bring this minus as it is and attach it as you open up the parentheses. You'll have a minus 1, then you'll have a plus 1 over 0. The problem right over here is this. This 1 over 0 is undefined. It makes everything undefined because when part of your interval diverges, everything is expected to diverge and you cannot do a good calculation over here. The limit will not exist as you can see over here. What we're looking here at a situation where you are only looking at a limit from one side and the limit will not exist as we're approaching the value, t values are approaching 0 from the right. We're going to end up extending into some sort of an asymptote grazing along it in the direction of either positive or minus infinity. When you're asked to evaluate this question, we're coming up over here minus 1 plus 1 over 0, which you can technically call either a positive or minus infinity based on how the graph would have been. We here have to state that our answer is divergence because in this specific instance we're not getting a clear determination for the area of that curve that's involved with this interval and with this rational function. What is our answer to this question? It's this, that the function is divergent over this interval. Our second question, the last question for this video, will be this. We have limit from 2 up to 3. We have 1 over root 3 minus m dm. We're using m here as our variable instead of x. Look over here, you have a rational function, but look specifically here. You can find the 0. 3 minus m is equal to 0. Minus m is equal to minus 3 and m is equal to 3, which indicates we have a vertical asymptote here at play. A vertical asymptote at 3. Our interval here could very well be distinguished and written in this form, 2 going up to 3 but not including 3 because a vertical asymptote arises. And that helps you establish this limit form. Limit as t will now approach 3, but you'll approach it from the left because you're going as you would along a number line 0, 1, 2 and then 3. You'll approach 3 from 2 from the left towards that 3. You're going to have this specific part come here 2 and going up to t. And then we have this remaining part right here, 3 minus m dm. The antiderivative needs to be determined for this specific integral, and it's going to bring a polynomial substitution into play. Look over right here, u is equal to 3 minus m, and then du is equal to minus dm, right? The minus will retain as a derivative of that m, and then dm is equal to minus du. But since we're using the polynomial substitution, we have to affect and change these intervals. This right here is my lower limit, upper limit. We'll have lower limit and new upper limit, right? All of that will change with respect to this. 3 minus 2, that'll be u1, and then 3 minus t, and that'll be u2. 3 minus t. Remember, it seems a little awkward and off the point here, but everything will work out. I guarantee that. Limit as t approaches 3 From the left, our new interval is now u1 is 1 and our u2 is 3 minus t. We have here 1 over root u. 1 over root u and then du. We have a minus du. I'm just bringing the minus right here at the beginning. But what I want to do is convert this 1 over root u into an exponential form, having brought it upwards right here. U to the power of minus 1 over 2. We know this right here is minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. Not too hard. We'll have this minus limit as t approaches is 3 from the left. We'll do the antiderivative here. U to the 1 over 2, and then here we'll have 1 over 2, and then we're going here from 3 minus t and then 1. This 1 over 2 will flip around and you'll bring a 2 in the numerator right over here, but I'm going to bring this 2 in the numerator right here along with this minus 1, and I'll make it minus 2. Think about it. I had a 1 or 2 which flips around, it hits with that minus, you get a minus 2. Now there's nothing more here other than to do the actual definite integration. Do not resubstitute back 3 minus m here in place of this, because we're doing polynomial substitution technique with definite interval at play. If you resubstitute this 3 minus m back here, then you must re-modify these new limits back to the old limits. What do we get? We get minus 2. We'll eliminate this limit because we'll now actually use it. We'll have 3 minus t to the power of 1 over 2 minus 1 to the power of 1 over 2, which are basically roots. Now let's see what's this 3 minus t. 3 minus t is really a 3 minus 3, which is a 0. What we're seeing here is a minus 2, and then this comes out as a square root of a 0, which is a 0, minus root of 1 is just a 1. Remember, anything to the power of 1 over 2 is a positive square root, because that can be rewritten as this. It's just rewriting the same expression. Minus 2 times minus 1, we get a positive 2, and this represents an area of this representation from 2 to 3. If you were asked to say what's the area below the curve, or what's the area represented by that curve, your answer here is 2 and it would be right. But what your answer can really be here along with 2 is we see convergence. The reason why we see convergence here is because in all cases and instances this limit exists. The limit exists because it can be evaluated. It evaluates such that we end up with a good convergent value of 2, and that completes this question over here. Remember, this question had a little bit of a peculiarity in that you have to use a polynomial substitution technique whereby you have to modify the old intervals into new intervals and then play with that along through up till the finish. 2 is a good answer, convergence is a good answer, limits exist for this specific situation, and I thank you for watching this video. Stay tuned, have a nice day.